BYD built a battery that outlasts the car. Not the warranty. The car it charges in 5 minutes, survives a nail through the core. And Toyota, the brand that said EVs weren't ready, is quietly running their sedans on BYD's cells right now. Here's why that changes the math on everything. To understand why this announcement matters, you have to go back to 1995. That is when BYD started. Not as an automaker, not as a tech company, as a battery manufacturer, supplying cells to Nokia, Motorola, and every consumer electronics brand that needed cheap, reliable power. While Detroit was engineering transmissions, and Tokyo was perfecting combustion cycles, BYD was quietly mastering electrochemistry. That background created a completely different engineering philosophy. When legacy automakers decided to build electric vehicles, they approached the battery as a component, a part to be sourced, installed, and managed. BYD looked at the problem the other way around. They designed the car as a structure built to serve the battery. The powertrain, the chassis, the thermal management system, everything was engineered in service of the cell. That single difference in thinking led them toward a chemistry the rest of the industry had already dismissed. Lithium iron phosphate, LFP, had been around for years. It delivers lower energy density than nickel, cobalt alternatives, meaning shorter range per kilogram. On paper, it looked like the inferior choice, so most major manufacturers chased higher density chemistries, betting that maximum range would win the market. BYD bet on stability instead. They spent years refining LFP into something new, a flat, elongated cell format they introduced in 2020 under the name Blade. And to demonstrate what that stability actually meant, they did something no battery engineer would normally allow on camera. They drove a steel nail through a fully charged cell. A conventional lithium battery responds to that kind of puncture with thermal runaway, a chain reaction of heat, gas, and fire that is extraordinarily difficult to stop. The blade cell surface temperature spiked and held. No smoke, no ignition, no runaway. That one demonstration told the industry that BYD had solved a problem others had been managing around for years. But thermal stability alone was never going to move the market. Because by the early 2020s, the conversation around electric vehicles had calcified around 3 specific objections, and the people raising them were not wrong. Problem 1. Charging time. A DC fast charger at 150 kilowatts delivers roughly 80% charge in 30 to 40 minutes under ideal conditions. That is not a refuel. That is a scheduled stop. On a road trip, it means planning your route around charger locations, arriving with margin, and sitting long enough to eat a meal you did not particularly want. Gasoline drivers pull in, pull out, and are gone in 4 minutes. Problem 2. Range anxiety. Even with improving efficiency, the psychological weight of watching a state of charge number count down on unfamiliar roads is a real barrier. Range anxiety is not irrational. It is a rational response to sparse infrastructure and unpredictable real-world consumption. Highway speeds, cold weather, and air conditioning all compress the actual range below the advertised figure. Problem 3, the one no manufacturer wanted to talk about directly: the battery degrades. Over time, every lithium cell loses capacity. After 100,000 miles, many first-generation EV batteries hold meaningfully less charge than they did new. And when battery capacity drops, resale value follows. The single most expensive component in an electric vehicle has a visible expiration date, and buyers calculating the true cost of ownership over 5 or 7 years could not ignore it. This was the real barrier to mass adoption, not the technology, not the infrastructure, the math of ownership. BYD's response to all 3 problems arrived in March 2025 with the launch of its Super E platform, and the numbers attached to it are not incremental improvements. They are category shifts. Start with charging. The Super E platform operates on a 1000 volt architecture, a voltage level most of the global industry has not yet reached at scale. At that voltage, the system can accept a charge rate of 1 full megawatt, 1000 kilowatts sustained. At that rate, The vehicle recovers approximately 400 kilometers of range, around 250 miles. In 5 minutes, that eliminates problem 1 entirely. BYD frames it as roughly 2 kilometers of range for every second the vehicle is connected. That is not electric. Vehicle fast, that is faster than most people pump gasoline. The receipt takes longer than the charge. Now hold that figure and add the lifespan claim. BYD states that the Blade battery is rated for more than 5,000 full charge-discharge cycles. Work that out against a typical daily driving distance, and the math produces a potential lifespan exceeding 1 million miles. The battery does not degrade to replacement territory over the ownership period of any normal vehicle. It does not degrade to replacement territory over 2 or 3 ownership periods. The battery outlasts the car. That eliminates problem 3. The resale calculation. The degradation anxiety. The quiet fear that the most expensive component in the vehicle will fail before the loan is paid off. And the nail test from 2020 addresses problem. Adjacent concerns around safety at scale, particularly relevant as these cells move into the high-stress, thermal environments of megawatt-class charging. Here is where the story takes its sharpest turn. Toyota, the company that spent the better part of a decade arguing publicly that battery electric vehicles were premature, that the infrastructure was not ready, that customers were not prepared, is currently installing BYD's Blade battery into its own BZ3 electric sedan sold in the Chinese market. The most cautious major automaker on Earth looked at BYD's cell and decided it was good enough to carry their nameplate. That is not a supplier agreement. That is a verdict. Toyota's decision to source Blade cells is a data point. But it is not the whole picture. The broader competitive landscape has accelerated sharply. Geely has announced an LFP cell, claiming a service life of approximately 50 years and over 600,000 miles under their testing methodology. CATL, the world's largest battery manufacturer, has stated publicly it is targeting a 1 million-mile pack as a near-term product goal. These are not theoretical research milestones. They are production targets with timelines attached. And the market position of these two companies makes the stakes clear. BYD and CATL combined manufacture more than half of every electric vehicle battery produced globally. The chemistry, the cycle life targets, the manufacturing scale. It all flows from two companies operating out of the same country, optimizing against the same internal roadmaps. BYD has also announced infrastructure to match. More than 4,000 megawatt class charging stations planned across China, purpose-built to feed the Super E platform's 1 megawatt appetite. The vehicle and the grid are being co-designed. That is not a charging network, that is a system. Toyota's own solid-state battery program, widely cited as its long-term answer, is not scheduled for production until 2027 or 2028. Volkswagen, GM, and Ford face similar timelines on their next-generation cell programs. The gap between announcement and production has historically been a place where battery claims lose credibility. But BYD's Blade is not an announcement. It is in production vehicles. It is in Toyota's vehicles. The cycle life data is accumulating in the real world, not a laboratory. And the application space extends well beyond passenger cars. The same LFP chemistry running in a sedan is being evaluated for long-haul trucks, transit buses, commercial shipping, and grid-scale energy storage. A cell that survives 5,000 charge cycles in a car can absorb a decade of daily cycling in a stationary storage application. This is the part that tends to get lost when the story gets filed under EVEV News. BYD did not build a better car battery. They built a cell that is beginning to outlast the definition of what a car battery is supposed to be. When a component exceeds the service life of the product it powers, the economics of that product change permanently. The ownership calculation changes. The resale market changes. The insurance models change. The way manufacturers think about warranties changes. And when the most conservative major automaker in the global industry quietly sources that cell for its own vehicles, without a press conference, without a partnership announcement, just a procurement decision, that is the clearest signal available that the shift is real. The battery that charges in 5 minutes and survives 1,000,000 miles is not a future product. It is in production. It is in Toyotas. The question worth sitting with is not whether BYD is overselling the number. The question is what the industry looks like when the number is proven out. That conversation is just starting.